This is review. This is the normal curve part of the review. Just a couple quick reminders. We took a quiz on this. It's been a while now that we're in two variable stats. Say one variable stat. And every time you do this, you should make a normal curve fast. Okay? Put the mean on there and know what the standard deviation is before you do anything. Okay, so if we know the probability, if we know a decimal value or a percent, then we're going to use inverse norm. If we don't, we're going to use norm CDF. So we have norm CDF and we have inverse norm. Okay, so this one 75 to 85, same distance apart, doesn't matter though. I'm going to just put in, go to distributions, norm CDF, lower 75, upper 85, mean is 80, standard deviation 14. This is what it looks like if you don't have a TI-84, 0.279. That would mean 27.9% of the data is between those two values. Notice that's less than one standard deviation away. If it asks for one standard deviation, that would be 94 and then 66. Okay, probability that our value is less than 90. Notice I'm making the normal curve again. Took me a really long time. So 90 is there. I want to know the probability that I'm up here, so I'm going from 90 to forever. So normal CDF, 90, 1 to the 99th, same other stuff, 0.2375, so 0.238. Probability that I am less than 77. Again, make your normal curve. 77 is here. That way if you get an answer like this, you get an answer bigger than 50%, you know something's off. So normal CDF going from negative big to 77. Other stuff stays the same. Those of you that don't have a TI-84, you can hit second enter and the last thing comes up and you can edit it right there. 0.415. So it's less than 50%. I can see that. Okay. Suppose X is an element, blah, 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 numbers that this is what you need to know. This is mu and sigma is 8. Even though it says 8 squared, it's 8. Probability that X is less than some number is 10%. So I'm putting my 30 on here. I'm making a picture every time. Down here, 10%, that's 0.1. My calculator will tell me anything to the left of my line. So it will tell me the K value that's to the left of my line. So distribution, inverse norm, area is 0.1, mu, 30, standard deviation 8, boom, 19.7. That's a number. Probability that X is greater than K is 0.6. This one seems to cause people problems. I think it's because they don't make a picture, because it takes a really long time to make a picture. 60%. The probability that X is greater than a number is 60%. So my number %, is out here. I have to use 40% in my calculator. I'm just going to do second enter because my calculator only tells me stuff to the left. So that rounds up to 28.0. And let's see if it makes sense. Does it make sense that the probability that X is greater than or equal to 28 is 0.6? Well, it should be bigger than half because 40% is less than that. So you can always check, if you want it, you could check to see, do 28 to infinity on your normal CDF, and that will check it out for you. We have normally distributed weights, mean, standard deviation. Mean is 17. Standard deviation 3.4. Between 10 and 15. 10 and 15. So I know it's all lower than. So if I go between 10 and 15, I'm using normal CDF. 10 to 15, 17, and 3.4. .258. 300 suitcases are presented for check-in in over an hour. How many of these would you expect to be lighter than 20? Okay, I'm going to use the same picture here. So I'm going to put 20. So I can find this probability first. So I need to find the probability that I'm going from, and I'll just go back to this. Lighter than 20 means negative small to 20, same other digits. Push the wrong button. So I want to know from negative all the way up to 20. I got that in there. 0.0470. So I'm looking at my answer and I'm going, something is not right here. Because there's no way that I could have 0.0470 for this whole area, which is again why you make your picture. So I bet something is wrong on the entry, even though I didn't check it last time. What if you just try to make the lower bound be some really small number? Let's see, maybe I entered something wrong. Oh, something wasn't reading right there on my calculator, and I'm not going to take the time to figure out what it was, but by using this picture I realized 81.1%. And that's part of the answer, but there are 300 suitcases. Expected value means I'm going to take that times 300, so 243 suitcases. Again, the picture helped me. I think there was probably something with a negative that screwed up the 10 to the 99th. But don't just take the number that comes out of your calculator and go with it. 3.9% of the suitcases are rejected because they exceed the maximum weight limit. Okay, maximum weight limit is right here. It's got to be above the mean. It's going to be kind of an extreme value. 3.9% rejected there. So they want to know, what is this K value? We know the probability. Our calculator tells us stuff to the left. Some of yours does more than that. So I want to know this area. Well, that's going to be 1 minus 0.039, which is 0.961. That's what I'm going to use for my inverse norm. Inverse norm, 0.961. Mean 17, standard deviation 3.4. If all you're doing is watching me push the buttons, I keep getting faster at this, and you just get better at watching me push buttons. Make sure you're doing this. 22.99, which rounds up to 23. So our weight limit maximum is 23. Come back with a video for the other one later.